morning children, and welcome back to your chemistry class. So in the chapter of hydrogen, today we are going to study the laboratory preparation of hydrogen. So what are the reactants used for the laboratory preparation of hydrogen? The reactants used are the granulated zinc and dilute HCl or dilute H2SO4 acids, right? Now, why do we use granulated zinc and why do we use dilute HCl and dilute H2SO4, not dilute HNO3? So before I begin with the explanation of laboratory preparation of this hydrogen, let us first understand. Now, granulated zinc is used or it is preferred for the preparation of hydrogen in the laboratory because it contains an impurity which is copper, and this acts as a catalyst and enhances the rate of reaction. Therefore, granulated zinc is preferred. Now, no other metal is used over here. So, what is the reason? Like sodium and potassium, they are violent with the acids, right? Calcium and magnesium, they are expensive. Aluminium, they will form a coating of aluminium oxide. Why? Because aluminium, it has a very strong affinity for oxygen. Clear? So we do not use aluminium also. Now for iron, it has to be heated, thus it will produce impurities like hydrogen sulfide, right, and sulfur dioxide. Lead, it forms a coating of lead chloride or lead sulfate which hinders to proceed the reaction. And all the metals below hydrogen, they do not replace hydrogen from the acids. Therefore, we use granulated zinc. Okay. Now talking about dilute HCl and dilute H2SO4 only. Why not dilute HNO3? Because as I had told you in the previous video that dilute HNO3 is a strong oxidizing agent, right? What does it do? It oxidizes the hydrogen into water and defeats the purpose of collecting hydrogen gas, and it also forms nitric oxide. These two reactions I had explained you in the previous video also. So that is the reason why we do not use dilute HNO3. Now let us go back to our reactants, granulated zinc and we take either HCl or dilute H2SO4. So some small pieces of this granulated zinc, it is placed in the flat bottom flask and it is fitted with an airtight cork, right, with two holes in it. Therefore, from one hole we pass a thistle funnel and which has a long stem, and through the other we pass a long delivery tube that you can see in the figure over here. Now, when we pour this dilute HCl through the thistle funnel, what will happen? The zinc will combine with the dilute acid to form zinc chloride and some effervescence is formed over here. Okay, what did I say? Some effervescence or bubbles were seen. This is the observation. And what can we say? What were those bubbles? They were the hydrogen gas. Okay, if you use dilute sulfuric acid, then zinc combines with dilute sulfuric acid. Here you can balance it. Will form ZnSO4 plus hydrogen gas. Here also, whenever we talk about hydrogen, the observation always be your effervescence or bubbles can be seen. I hope this point is very clear to all of you. Now further, how do we collect this gas? Collection of hydrogen gas. So this is always collected by the downward displacement of water. Now, why are they collected? Why is hydrogen gas collected by the downward displacement of water? There are two reasons. Firstly, it is insoluble in water, right? So, one reason could be it is virtually insoluble in water, right? And second point could be that it forms an explosive mixture with the air, and therefore it cannot be collected by the downward displacement of air, even though it is lighter than the air. Okay, so we can say it forms an explosive mixture with air. So due to these two reasons, we say that we obtain or we collect hydrogen gas by the downward displacement of water. Now, while collecting hydrogen gas by the downward displacement of water, we also obtain certain impurities. What are those impurities that we collect? While collecting hydrogen gas, we even collect those impurities, like for example, hydrogen sulfide, okay, then even sulfur dioxide, even your oxides of nitrogen can be obtained, then even the phosphine, the formula of phosphine is PH3, okay, then fifth one is arsine, that is AsH3, then carbon dioxide and even water vapor. So these are some of the impurities that are formed while collecting hydrogen gas, right? Now, how can we get rid of these impurities from hydrogen is what we are going to study next. Now here we shall study how the impurities can be removed from hydrogen by passing it. So for the first solution that we use is your silver nitrate. Okay, silver nitrate means AgNO3. This is used to remove arsine and phosphine. It removes arsine and phosphine. Okay, so AgNO3, when it combines with arsine, that is AsH3, what is it going to form? It will form silver arsine plus silver nitrate will be formed, plus nitric acid will be formed. Some part of silver nitrate will be left unreacted. Okay, even with PH3, this silver nitrate, it is going to form what? Silver phosphide plus some part of AgNO3 will be left unreacted and HNO3 will be formed. You can balance the equation, or let me just balance the equation. This is 6HNO3, this will form 3HNO3, okay, and this is 3H. So this is balanced. Now let us look at this one. Here again 6AgNO3 combines with phosphine to form your silver phosphine plus 3AgNO3 plus 3HNO3. Okay. Then second liquid required to remove an impurity should be your lead nitrate solution. Okay, lead nitrate is PbNO3 whole twice. This is used to remove hydrogen sulfide. Okay, So H2S, and thus it forms lead sulfide and HNO3 will be formed over here. Thirdly, we can use caustic potash solution. What is caustic potash solution? KOH. And all the carbon dioxide and oxides of nitrogen can be removed with this. So if KOH is added, then it will remove sulfur dioxide, forming K2SO3 plus H2O, right? This KOH can also remove your carbon dioxide, forming K2CO3 plus H2O. And even we have oxides of nitrogen, so KOH can be added for the oxides of nitrogen also, and here it will form potassium nitrite plus potassium nitrate, and water will be formed over here. Clear? So this way we can remove all the impurities. Now next we talk about what is the drying agent used over here. Now see, since this gas is collected over water, that means moisture is present in the gas and we need a dry gas. So how can we obtain a dry gas? By passing that moistened gas through a drying agent. So which drying agent do we use over here to get the pure dry hydrogen? So we can use the common drying agents like fused calcium chloride can be used. Okay, then even we can use like caustic potash can be used, or even we can use phosphorus pentoxide, right? So phosphorus pentoxide, they all can remove water from the moist hydrogen gas and makes the gas dry. So the gas is purified after passing through the drying agent, and then it is collected over mercury. Why? Because mercury, where is it placed? Below hydrogen in the activity series, and therefore it will not react with hydrogen at all, and hence it is kept in the mercury. Or what is kept in the mercury? Purified and dried hydrogen gas is kept in mercury. Purified and dried hydrogen gas is collected over mercury. I hope you understand why it is collected over mercury. What did I tell you? Because mercury, it cannot react with hydrogen gas. Why? Because it is placed below hydrogen in the activity series. Clear? Now, we cannot use concentrated sulfuric acid over here as a drying agent. Why we cannot use over here? Because it will combine with hydrogen and will defeat the purpose of collecting hydrogen gas. That is, for example, say if we use I'll show it to you over here. So if we use H2SO4 as your drying agent, right, and hydrogen gas is passed through it, do you know it will give us water and sulfur dioxide. So where had we obtained hydrogen? We do not obtain hydrogen. So this defeats the purpose of collecting hydrogen, and therefore sulfuric acid, concentrated sulfuric acid, it is not used. This is a drying agent also. This is not used for drying moist hydrogen gas. Right? Now we come to some precautions. What precautions do we take while conducting this experiment? The apparatus should always be airtight and there should be no leakage of the gas. Why so? Because we know that this gas is highly explosive when it comes in contact with the air. So there should be no flame also around to burn any of the apparatus there. Then this gas should be collected only and only after all the air in the apparatus is escaped, right? And lastly, the end of the thistle funnel, remember, it should always be dipped under the acid, so to prevent the gas not from escaping through the thistle funnel, because if it passes through the thistle funnel, then explosion may take place. Okay, and the last part for today, let's talk about the test for hydrogen. Okay, so only two things that we need to learn over here. Firstly, that hydrogen is combustible, but it does not support combustion. Highly combustible but does not support combustion. Okay, and the second point, it burns slightly in the air, or we may say in the presence of oxygen, with a pale blue flame, right, forming water, right? That is hydrogen combines with oxygen, burns in the presence of oxygen and forms water. So when it is premixed with the air or oxygen, it explodes with a pop sound. When premixed with air or oxygen, it explodes with a pop sound. Okay, so that's all for today. In the next video, we shall talk about the manufacture of hydrogen. Today, we were only discussing about the laboratory preparation of hydrogen. Thank you.